Hello, I have written a few equations here. We are going to learn how to make a particular variable the subject of the formula. Look at the first equation. This equation has variables x, y, and m. We want to make x the subject of the formula. Take a look. In this equation, x is present at two places, here and here. To make x the subject, we will need to collect all the x from both sides to one side of the equation. So I am transposing mx from this side to this side of the equation. When I do that, mx, which is positive here, turns to negative mx, and I get x plus 2y minus mx is equal to ny. I have 2y on this side. I need to transpose it to other side of the equations because I want x to be the subject. So all the unwanted variables that do not have x need to be transposed to that side. So I have 2y, which is positive here. So when I transpose it to that side, it becomes negative 2y. And I'm left with x minus mx is equal to ny minus 2y. Now from here, I want x. If you see x is present at both the places, so I can take it out common from both the places and I end up with 1 minus m ny minus 2y. Even though these two terms have y as a variable, we cannot subtract them because this y has another variable n with it. So these two terms remain as they are. On this side, I have 1 minus m multiplying with x. So I need to transpose 1 minus m to that side. You need to see what operation is being performed between this bracket and x. So this is multiplying x. So when transposed to that side, it will divide. It will go in the denominator. And I have x is equal to ny minus 2y whole upon 1 minus m. So this is the formula that I wanted. So if you see, I have x to the left hand side of the equation and I have everything else being transposed or shifted to the other side. This is how we make x the subject of the formula. Look at question number 2. I want to make a the subject of the formula. So I will transpose one by one everything else other than a square to that side of the equation. So the quantities that are either adding or subtracting this fraction, they will be transposed to that side. So 5, which is negative here, when transposed to that side, it becomes positive 5. And I have a square by 2b is equal to 9b plus 5. Next, I need to get rid of this 2b. 2b is dividing here. So when that side, we transpose it to that side, it multiplies. So I'm left with a squared is equal to 2b times 9b plus 5. So when a quantity is transposed from that side to this side and it multiplies a binomial, we put the binomial in brackets always. You need not expand this bracket because it will make things look complicated. However, you can go ahead and expand. Next, Is this the answer? We have a square on this side and everything else on the other side? No, because I want to make a the subject, whereas here I have a square the subject. So I need to get rid of this square. So for this, I need to take square root on both sides. So when I take square root on both sides, I have a squared, square root of a squared is equal to square root of 2b bracket 9b plus 5. We cannot find the square root of this because we do not know their value. So they are left in the bracket as they are. So I write the next step. Square root of a square is a, and this side remains as it is. I have 2b, 9b plus 5, and this is how we make a the subject of the formula. In the third equation, I want to make m the subject. That m is enclosed in the square root. I need to set it free from the square root sign. Before that, see, we have this 2 denominator which is not inside the square root. I can get rid of this 2 just like that. So 2 is dividing this side. When transport to that side, it will multiply 3n plus 1. So I'll have m plus n is 2 times 3n plus 1. As I said earlier, if you multiply a number and a binomial, that binomial needs to be enclosed within brackets. So since we want this m out of this root, I'll have to square root both sides. So when I square root both sides, square root and square are opposite operations. So when I square m plus n, I have root of m plus n squared. So things are squared both sides. I get 2 squared 3n plus 1 squared. As I told you, root and square are opposite operations and they cancel out, and I'm left with m plus n is equal to 2 squared is 4, and I am not squaring it, I am leaving it as it is, 3n plus 1. It is your call, you can go ahead and expand this bracket. Again, since I want m the subject, this m, I will transpose n to that side. So n, which is positive here, when transposed to that side becomes negative n. I am left with m is equal to 4, 3n plus 1 whole square minus n. So this is how we get the subject of formula when the subject is enclosed inside the root sign. In the fourth question, we want to make y the subject, and that variable is in the denominator. Your subject cannot be in the denominator. It should be written in the numerator. So what I do is, I'm going to be shifting this y plus 2 to that side of the equation. So here it is dividing, but that side will multiply 6. So d is equal to 6 times y plus 2. Why do we enclose y plus 2 in brackets again? It is because it is a binomial. So when I expand the bracket, 6 multiplies both the terms of the brackets. Okay, again, do we need to expand the bracket here? Yes, because the subject that we want is enclosed in the bracket. We need to set it free. So I multiply 6y, I get 6y plus 6 times 2, 12. I want y again. So what I do is, I send it to this side and I get d minus 12 is equal to 6y. Lastly, I transpose this 6 to that side and I get 6 times, since 6 is multiplying here, so that side it will divide and I get d minus 12 by 6 is equal to y. So here I get y as the subject of this formula. You can also flip it and write it as y is equal to d minus 12 by 6. This is my answer. I hope it was helpful. Thank you.